All right, I've changed the numbers on this from yours, so make sure you take note of that. It says, suppose a set of billiard balls was 3 1/4 inches in diameter. The rack used to group 15 billiard balls is the shape of an equilateral triangle. What's the approximate height of the triangle used to form the rack? So they showed us a rack here. It's an equilateral triangle, so we know all sides are the same length. Okay. We're trying to find the height, which would be this length right here, straight up through the center. Again, with an equilateral triangle, remember all the sides are the same length, but also all the angles are 60 degrees each. So this was 60, this was 60, and the top here was 60, but notice we've split it into two equal angles. So here would have a 30 next to a 30. Okay, so as I look at that, if I just pull one of those triangles off to the side, I notice that I have a 60-degree angle here, a 30-degree angle here. Okay? They want to know the approximate height. So where was the height? That's our distance straight up the center here. I'm going to call that my x, and it would be this side right here. Okay? What part do we know? Well, we know that each of the balls is 3 1/4 inches in diameter. And we can see that one of the sides here has 1, 2, 3, 4, 5 balls end to end. So the length of one side is the same as 5 times 3 1/4. Now to make this a little better for us, since a lot of people don't care for fractions, you can rewrite that as 3.25. A quarter is 0.25. Okay, so let's do it that way. So we have 5 times 3.25. There were 5 balls, and again, each of them had a diameter, a distance across of 3.25. So that gives me 16.25 is the length of one side from end to end on this triangle. But notice I'm only dealing with half of that side. So I'm going to now divide that by 2. And I get 8.125. Okay, so this would be right here 8.125, as would this. So over here on my little drawing, at the bottom here is 8.125. Now this is a 30, 60, 90. The side I'm looking for, here's my hypotenuse, which right now I really don't need. That's not what I'm looking for. This would be my short leg. It looks shorter and it's across from the smaller angle. And here's my long leg. So I am looking for the long leg. So I look in my formulas for 30, 60, 90, and I notice that the long leg is equal to the short times the square root of 3. Okay, well, that would give me my x is equal to the short leg, which was 8.125, times the square root of 3. Now it wants my answer rounded to the nearest tenth, so I'm just going to take out a calculator and multiply that. And when I do, I get 14.0729. Okay, it wants the... Alright, so we want that value. It says it wants it to the nearest quarter of an inch. Well, 0.0729 is not, a quarter would be 0.25. So if you're close to 0.25, it'd be 14 1/4. But here we have 14, if it's 14.5, that's 14 1/2. If it's 0.75, that's 14 3/4. But we're very close to 0 here. So the nearest quarter of an inch would just be 14 inches for us. Okay, here we have a mirror shape in the shape of an equilateral triangle. So again, we're dealing with a problem that involves an equilateral triangle. Again, that means all the sides are the same and all the angles are 60 degrees. The length of one side of the frame is 38 inches. Okay, so 38 inches on all of these sides. It says, will the mirror fit on a wall above a mantel that's 34 inches below the ceiling? Okay, so they're saying you have a mantel right here and you want to put the clock on top of it. Okay, but the distance here is 34 inches before you hit the ceiling. So they want to know, are you going to be able to fit the clock there, or is the height of this triangle too big? So if the height is less than 34 inches, it's going to fit. If the height is bigger than 34 inches, it's not going to fit. So we need to find the height of that triangle so we can determine whether it will fit or not. Again, the height goes straight up the middle and makes a right angle. And when it does that, drop this down here. Notice it creates a 30, 60, 90 triangle. Again, here's our height that we want to find. We know this is 38 inches. And what would this bottom part be? Well, it's half of the 38 because it's cutting it right in two. So it's also our short side. So 38 divided by 2 gives me a length of 19. Okay, we want to find our height. Well, here's our hypotenuse, here's our short leg, and we need to find our long leg. So look in your notes. In your notes you should have the formula that says the long leg is equal to the short leg times the square root of 3. So our height, the long leg, is equal to the short leg of 19 times the square root of 3, and we just take out a calculator and multiply, and I get 32.9 approximately. Okay, now the question was, is this going to fit on the mantle? So if the height of this triangle is 32.9, is it small enough that it doesn't hit the ceiling? Yes, because 32.9 is smaller than 34, so it's going to fit with a little bit spare on the top. So yes, this will fit on the mantle. Had it been larger than 34, it would not have.